Hello everybody, so I introduce myself. My name is Mohammed Ibn Isa. I'm a PhD student at Tunisia Polytechnic School, and today I will present the different decision architectures from business intelligence to big data. This work was elaborated also with Dr. Lilia Sfersi and Dr. Riyad Rabban. So the plan will be the following. We'll begin this presentation by introduce business intelligence and big data, and the difference between them, the different decisional architectures from business intelligence to big data, and finally how to make a choice between them. So in this slide, you have the definition of the business intelligence term, which includes applications, infrastructure, tools, and best practices that enable access and analysis of information. So by design, business intelligence technologies were designed for decisional needs. In the other side, big data technologies were designed in order to store and treat high data volume with high velocity and with different structures. So big data technologies are not specially designed for decisional need, but can be used in this context. In this slide, we have a comparison between data warehouse, which is used for BI needs, and data lake, which is used for big data decision needs. So data warehouse is more oriented for structured data with important volume and not very high volume. Is characterized by high information density and a centralized storage. In the data warehouse, we can find a collocation of the processing and the storage, and the scalability is vertical and not horizontal. In the other side, data lake can support unstructured and denormalized data, can support also high data volume thanks to its horizontal scalability and distribution. We can also find other features like the collocation of the processing and the storage. So here in this slide, we have the classical BI architecture with the different phases. So the first phase is the ETL, which means that we'll extract, transform, and load data from the different production database and the sources into the data warehouse for the warehousing phase. And then we'll begin the analysis via the OLAP cubes. And finally, we'll have the restitution and the visualization phase via the different database tools. So the problem of these sort of architectures is that it doesn't support a high data volume because technologies are centralized and not distributed. We can't also do very complex analytics because we need a lot of RAM and CPU, and it's not possible with this sort of technologies. And finally, also we have only batch processes from the beginning to the end of this architecture. So real-time and stream processing is not supported in this use case. And now we see the different big data architectures, or the integration of big data in the BI architecture in order to resolve these problems. So here in this first slide, we can see the integration of the big data technologies only in the ETL phase. And thanks to this integration, we'll be able to extract a high data volume and to do a lot of cleansing and enrichment in order to store the results in the data warehouse. So thanks to this integration today, high volume extraction is supported by these sort of architectures. There is different technologies that can be used for this in this context, like Apache NiFi in the HDF or Hortonworks stack. There is also StreamSet in the Cloudera one, Apache Kafka Connect in the Confluent stack, or we can use also other technologies like Talend or Intel. Then here we can find the second integration of big data technologies, but now it will be in the warehousing phase. So the idea is to have a big warehouse that will be that can extract data from the different sources and also store high data volume by applying a structure to store data. So the advantage of this architecture is that now we can extract and store high data volume, and then we can do also complex analytics thanks to the collocation of the storage and the processing. Technologies that can be used for in this context are Apache Hive, Apache Impala, Presto, Zoom Data, or also we can find other solutions like Apache Kylin or Redscale. Now we can find another architecture, which is the big analytics one, that will introduce big data technologies in the analytics phase. So the idea is to use technologies like Spark, machine learning, or Flink also, in order to do analytics with big data technologies. And thanks to this integration, it will be possible to do complex analytics in the BI chain. So as I said, there is a lot of technologies that can be used in this context, like Spark MLlib or Flink ML, or also other stacks like Cloudera Data Science Workbench or IBM Data Science Experience. Now here we can find also other solutions in order to include the data lake in the BI architecture. So the idea here is not just to integrate big data technologies, but also to have new storage, like new storage like the data lake. Here in this figure, it will be before the data warehouse in order to store the entire data and then do some cleansing and enrichment processes in order to enrich the data warehouse. And thanks to this architecture today, we can implement important features like the high volume extraction and storage, and also complex analytics and historical analytics. We can find also a second architecture with the integration of the data lake, but by having data lake and data warehouse in parallel. So it will help to keep the historical data in the data lake, and then to have also the different analysis in the warehouse one. So technologies that can be used in this context are Oracle Big Data, Polybus solution of Microsoft, Big SQL of Hortonworks and IBM, and finally we can use also directly Apache Spark SQL or Apache Flink SQL. And finally, we can find also pure big data architectures that can respond to BI, to decision needs. Sorry. So here we can find the, for example, the Lambda architecture with three main layers. The first one is the batch one for batch analytics. The second one is the speed layer for real-time analytics. And finally, you can find the server layer in order to represent the different results of batch and speed layer. And thanks to this sort of architectures, it will be possible to have real-time and stream processing in the decisional world. One of the technologies that implement this architecture is Apache Druid. We can also find other big data architectures that, like the Kappa one, with only real-time layer without the historical one. And the idea here is to have only real-time and stream processing for the decisional queries. So it's also a very important architecture. And this sort of architectures of architecture can be implemented via the data artisan stack and Apache Flink streaming, or with Apache Kafka also in the Confluent stack. Now here we present a tree in order to help the decision making about the different architectures that we present. So as you can see here, the first question that you have to ask is, should we have real-time processing? If yes, the only architecture that can respond to this need is the big architecture. Then the second question is, do we have fixed KPIs? So if we don't have, we can use data lake and data house in the same architecture, or if it's not the case, so here we have to ask a question about the volume, the data volume. If you have more than 100 terabytes, it's more interesting to use big warehouse architecture. If it's not the case, we have to ask another question, which is, should we extract a high data volume, means more than 1 terabyte per day? If it is yes, so here complex analysis can be, here we have to ask another question, sorry. So uh, should we manage complex analysis? If yes, big architecture would be the good solution. If no, the big ETL would be the good solution. And then here, if we have a high data volume to extract and we don't have complex analysis, so in this case, BI architecture can respond to this need, and the other case, big analytics can be a good solution. So in the conclusion, it is very important to know that for each situation there is a solution. We cannot have one solution for all the situations. Big data solution will never replace business intelligence. And for most companies that have to implement decision and big data architecture, choosing the right setting in is the most difficult task, along with the integration of the different components. Thank you.